We were in the middle of our discussion about functions and the various ways you could describe them. We had the algebraic description as what we're traditionally used to a lot in math classes. We could describe it graphically, or graphically, again, you get a picture, and I can ask you to do calculus on a function. You know, what is the rate of change of this function? What's the slope of the tangent line? Where's the max and min? Or how much area is under the curve? We'll define those terms later. Or you get a function numerically, where you just get a set of points. You get a set of points, and a lot of times in real life, that's what you get. We have precision recording devices that record things at particular points in time. So you get a bunch of set of points. And this is actually a very convenient way for a computer to store a function. Computer storage. Okay, and then again, to make these consistent, let's say algebraically, graphically, numerically. Now, another way to represent a function students like a lot are the word problems. So I would maybe use the word verbally. I'll give you a word problem. We might give you a word problem and you have to come up with the function. A lot of times this makes problems, these are problems that students find more difficult sometimes. So let's look at a verbal definition of a function. So here you go. We got a rectangle that has a perimeter of 20 meters. Express the area of the rectangle as a function of the length of one of the sides. So again, in working any kind of problem, we want to draw a picture first. Correct? Any of these? We take something, we draw a picture. Well, I can draw a rectangle. Let's just start there. And a rectangle doesn't have to be a square, but a square is a rectangle. We'll call this, I don't know, height. Call this width. Write down some things I know about a rectangle. Well, they want the area here. Read this problem again. Area is going to be equal to height times width. But what do they want? They want a function as a length of one of the sides, one of its sides. This is a function here. We might even say that's a function of two variables. It's a function of height, comma, width. They want it of one of the sides. Well, what else do they tell me? Oh, the perimeter is 20 meters. Okay, so what's perimeter? Well, I got a height here, and I got a width here too. So perimeter is going to be equal, I got two widths plus two heights. So one of the sides, that means I got to get rid of, I need a single variable. I need a function of one input. Let's call it an input. Okay, so what are we going to do here? We'd say, oh, what's the perimeter? The perimeter is 20. I could do a little bit more with this function here, and I could divide both sides by 2. How about that? I'd say W plus the height, width plus the height has to be equal to 10. Now, I put this is 1 and this is 2. I now get my third expression here, and I'll say the area is equal to height times width. Well, what's width going to be? Well, width is just going to be 10 minus h. Okay, so you see I can set that's equal to width is equal to 10 minus h. I substitute into here, and I can now say, well, there's a as a function. It's 10h minus h squared. Okay. Does that answer the question? Yes, a rectangle has a perimeter 20. Express the area as a function of length of one of the sides. Okay. We could talk about this thing. Does it have its? Can you draw that function? Could you draw it? You'll have to be able to do that. We'll go there on this, but what are the what's the domain here? The domain. Well, if you go back to the real problem, I mean, certainly the height has to be positive, has to be greater than 0. I can't have a height of -2. It doesn't make sense in the physical world. So I'd say h, and I can't have it be equal to 0 or it's not a constant. So I'd say h is less than 0. Okay, now the range, I'd have to do a little more work on this. My area can't be negative. I have to almost, in this case, I could factor out an h and set this equal as 10 minus h, right? As I did here, really. Go back to that expression. And you can see the maximum. Where's the maximum going to occur? That's kind of another, let's see if I can extend this, see what it looks like when I do this. Going a little bit ahead of where I wanted to be, but okay, that's fine. Pen's blue. This is a quadratic expression, right? And again, we're going to go through a library of these functions, but here's an example of a function. You need to be able to know what it looks like. And of course, you'll have access to that graphing calculator sometimes, not all the time. On an expression like this, you should be able to do it without your graphing calculator. This is a of h. This is h. So here what do I have? I have a verbal description of a function up here, an algebraic description of a function, a graphical picture of the function. I want to know what the range is. Well, my range really, this doesn't make sense down here, right? Because my area is going to be positive. It's going to go between here and here. So actually, h, I'm wrong here. By looking at this, h cannot be bigger than 10. So not only h is greater than 0 and it's less than 10. My legal domain, go here, here's my domain right here, h less than 10, 0. And what's my range? Well, range is this way. Range, it looks like a of h has to be less than whatever this max is, and it has to be greater than 0. What's the max? We know if this is 10 and this is 0, we might know some properties that the max occurs symmetrically in the middle at 5. If I calculate then a of 5, I'm going to be equal to 10 times 5 minus 5 squared. I'm just plugging it into there, and I'm going to get 50 minus 25 equal to 25. So it looks to me like the range is right here. Here's my range of my function. Here is my domain. My function is a quadratic opening down. Okay, so my verbal description of a function got a little more involved than I initially intended, but again, a lot of good things going on here. We went from a verbal description to an algebraic description. Okay. To an algebraic description right here. To a graphical description right here. We used the graphical description, really helped me kind of see what the domain and range was. I almost made a mistake on the domain until I looked at the graph. And I realized, what does this really mean? Well, the area has to be positive. So the range has to be positive. It's between the area of the rectangle is between 0 and 25. That's my min to max. The domain has to occur where the area is positive, so that's between a height of 0 and 10. In the next video, we'll talk more about functional characteristics, and then we'll look again. We need to look in our library of functions that we need to be skilled at using. Again, here's a precursor to the ability. Could you do this? Can you take this algebraic description and kind of quickly draw this curve? Again, you're not going to have all the time sometimes to go to your graphing calculator. Too many extra steps. This is a common quadratic function with a 0 at h equal to 0 and a 0 at h equal to 10. And I knew because of the negative sign it opened down. So again, we need to be skilled like that with other functions. See you in the next video.